Alright guys, this video is just going to be a walkthrough of how I assemble all the components into an AutoVent and then install it onto a heater. So I lost the audio on this earlier, so I'm just going to go over and dub it. But what I'm showing here is just kind of I've got an assembled unit here showing the different components. You've got the power there on the left, servo at the top, that's the PCB with the USB port sticking out, that's the current sensor, the ACS758. And then you've got your power input there, AC on the left, DC on the right, and that's about it. So that's what the assembled unit looks like. So I'm just kind of going through and talking about everything that I kind of prepared before I start one of these projects. So here you can see I've got all the components laid out. I've got my boards up there at the top right, my wiring, the PCB, some of the different input and output jacks. Off to the side, what you can't see are some of the tools that I use that kind of I find are very helpful when I'm doing a soldering project, and I'll go through a few of those. So here's one. I really like this. This is an OmniFixo helping hand system. It's really great. I'm not going to go too in depth of this. You've probably seen these, but I've gone through a lot of different helping hands. This one is by far my favorite. All right, and then these, and I'll link these later. I found these on Maker World. These are like little header holders. So you can take your header pins for whatever, the SAMD chip or whatever, and you can place them in here. That'll hold it upright. You can put the board on top of there, and it just makes it a lot easier to solder headers onto things. So I'll put the link to that. I'll put the link to those down later. I don't remember who made those. And then of course this is just a vise. I find this useful to be able to like clamp in the PCB or different component boards or whatever. Just another helping hand. Sometimes I use that, sometimes I don't. All right, and then some other tools. I've got the heat gun there for heat shrink tubing. And then all your normal stuff, flux, solder, pliers. Just make sure you have everything ready to go. That way you're not doing like I normally do, and you're constantly getting up and down to get to your tools. Okay, so I like to start off with the MCU, and I'll solder the headers to the MCU and then the MCU to the PCB. This piece is pretty straightforward. Okay, I'm going to fast forward through here. This is just the process of first soldering the MCU to the headers and then the headers onto the PCB. So we'll rip right through here. Use flux and take your time and get good solder joints on every single one of these. There's the top, and then I'm going to attach it to the board, and you can just push this down as flush to the PCB as you can get it. Okay, so at this point I'm going to be grabbing my side cutters and cutting those headers off underneath the PCB. And the reason for that is because, as you'll see here, like we want to be able to run some of those cords underneath the PCB if we want to get them out of the way, and that'll eliminate any risk of snagging on those headers. So we're going to cut those off, clean up the board, and then we'll come back for the next step. Okay, now the next thing that I like to do is the headers on the PCB. And so you're going to have a total of 4 headers here. You've got 2 2-pin. Those are the ones at the top for the switch and the LED on it. There's a 4-pin on the right for the servo, and then the one at the bottom is a 90-degree 3-pin for the connection to the current monitor. These headers are all going to be soldered on in the same way, in that the longer side of the header pins are going to be facing away from the board, and the short side of the pins are going to be underneath. And that is because we're going to be plugging jumpers into them for the switch and the servo, etc. So the way I like to connect these, I'm sure there's a better way, is that I'll just kind of somehow get those pins in there best I can, and I'll lightly solder up one of the pins, just enough so it doesn't fall out, and then I'll kind of use my left hand to reposition the header while I'm melting the solder with the right hand, and you'll see what I'm talking about here in a second. Okay, so I got that on there. It's sticking, but you can tell it's not at a 90-degree angle to the PCB. And so I'll just kind of play with it with my left hand while I loosen that solder up, get it straight, and then I'll go through and do the rest of the pins. So that's one of the button switches we've done here. I'm going to go ahead and fast forward through the rest. Just make sure you get them in the right spot, and you've got that 90-degree 3-pin at the ACS connection, and I'll slow it down when we get there because I want to make sure you're hitting the right pins. It's going to be the left 3 holes, and you'll not put a pin in that 4th hole on the right. Okay, so here we're putting on the 3-pin, and like I said, all you want to do is you want to make sure that it's in those left 3 holes, not the one on the furthest to the right. All right, so we'll get this soldered on, and then we'll go on with the next step. Okay, so here we're going to go ahead and put that 2-position terminal on. And this is pretty straightforward, but all you want to do, you want to make sure that the opening for the wires is facing away from the board. Okay, now next I like to put the ACS on, and I want to do this before I do the capacitor because when I put that cap in, it's going to have to lean out just ever so slightly, and so I want to make sure that I got that board in there first. When you put the header into the ACS, you just want to make sure that your VCC, your power pin, is that rightmost pin, and then you've got the header underneath, and that way it'll fit on the board and face away from the MCU. Okay, now we're going to attach the ACS to the board. And so here the only thing you need to be aware of is you need enough room to hook the jumper up to that 3-pin header. So what I like to do is just take the empty, either an empty header or you can just take that data cable, go ahead and plug that in. Yep. And then just make sure there's enough room. So you want the board high enough that you can fit that in there. Normally there's just going to be a little bit of the lead sticking out underneath the board. And that's good enough. Okay, now with the ACS on, I'm going to go ahead and put the capacitor on. And when you put the capacitor in, it's marked with a negative right there on the capacitor. Just make sure that's going into the shaded area on the board. So I'm going to stick it in there, splay the leads a little bit just so it sticks, and then I'm going to go ahead and solder it in from the bottom. Okay, that's it, and then I'm going to go ahead and clip off the leads of the capacitor. Alright, so there is the completed main board. At this point, all I need to do is clean the flux off of it, and that piece is done. Okay, I'm not going to wire up an ACS. I already had one here soldered together, so I'm just going to show you. This one's pretty straightforward. You just need to solder a 4-pin header on that end, and then the other end gets the 2-position 5mm terminal. Again, with the leads, or the opening for the leads facing outward. You can put the actual ACS chip either on the top or bottom of the board. Here I've got it on the top. If you put it on the bottom, it just makes it maybe more difficult to run some of the wires underneath that board if you end up wanting to do that. But either way will work. Okay, now the next step for me is going to be to wire up the 5-volt input. So I'm going to grab the barrel jack, strip the wires, and solder on the positive and negative. So I'm going to go ahead and fast forward through that. Okay, we've got the 5-volt barrel jack all wired up, exposed leads heat shrunk, and ready to go. So from here, we're going to move on to the switch. Okay, now with the illuminated switch, it's got 6 leads on it. 2 of them are for the LED, and so the cathode for the LED is on the side with the line facing outward. Yep, so right there, that's the cathode. The other side opposite that is going to be the anode. So that'll run the LED. For the other ones, you can choose any 2 as long as they're on the same side. So I'm going to go with those 2 right there. That'll be for the actual button itself. Okay, now with the switch and the LED all wired up, we will move on to actually assembling the entire AutoVent. Okay, let's go ahead and start putting some of this together then inside the enclosure. So grab your plastic parts. If you haven't printed these yet, you can get the files off of MakerWorld. I'll include the link in the video description. You can also purchase these components on your own. I sell these on my website, 3dcreator.shop. You can get kits, you can get individual components. I sell also the TPU in case you don't feel like printing TPU, the gaskets. So check that out. You can get whatever you need there. Okay, I'm going to start showing you how to assemble some of these components here, and I'm just going to run it in 4 times the speed. But so I've got the power switch in there, put the cables out of the way just for now. Now the servo, when you put it in, make sure that gear is offset on the body. Make sure it's closer to the center, and you've got the wires coming out towards the center of the enclosure there. The screws for mounting it in, you can see here, I'm using M2 screws. Just put the screws in through the posts. Use a pair of needle nose pliers to hold the nut and then screw it in. It can be a little tricky, but it's not too bad. And then here I'm just kind of figuring out what I'm going to do with these wires. I normally just kind of circle them up like this, stick them underneath the PCB there. So I'm going to do that, put the PCB in place. I'm going to hold it in place with 1 screw for now. But that's enough to get some of those wires out of the way. And however clean you want to be with this install, that's entirely up to you. You can try to run all the wires underneath. I'd kind of do half and half, but you don't have to do any of them. It's whatever you prefer. Okay, here I'm going to go ahead and install the ACS board. It goes right next to the PCB. You'll see the two screws it screws into. Now here I'm going ahead and kind of stripping off the ends of the AC power line, and then I'm going to take off some of the insulation from the leads so I can solder that up to the plug.
Okay.
Okay, now I'm going to go ahead and take the AC line and I'm going to feed it in through the
What I like to do
power
is
opening
pass this
in
through
the enclosure.
here.
Now I forgot to put the
Then I'm
grommet
going
in
to put
here,
a
so
strain
don't
relief
forget
knot
to put
in, but
that
I'm going to put
TPU
it way up
grommet in
here just
before
to
you
give me
do this.
room
And I'm
to
tying
work
the
with this
knot
wire.
really close,
And then I'll move
just so I
it
can have some more working
when it's
room
all done.
with the wire to hook it up to the ports and
So
stuff. And I'll change
this
that. I'll move
connection, and
that
this is
down
the
when we're
last
all
little
done
bit of
here.
soldering you have to do.
All right, I'm going to speed this up as I connect the AC line. All you have to keep in mind is um, you're going to have one lead from the input that goes to the IP minus on the ACS 758, and then the IP plus is going to connect to the cord and go into the heater. The other wire from the heater is just going to go directly to the input, and you'll see that here when I have it all wired together. Okay, we got the AC line all buttoned up, moved the stress relief knot up, and that's all good to go. So the next thing is we're going to put the servo gear on. So there are some small splines inside. Just press that on and then find the screw that came with it and attach it securely to the servo. Okay, now we're just going to connect the ACS board and the main board. And you're just going to match up power to power or 5 volt to 5 volt, ground to ground, and then the signal lead. And then we're going to install the 5 volt barrel jack. So this is pretty straightforward too. Place it through the hole, put the nut on, tighten it up, and then you're going to connect the power and ground to the main board on that 2.4 millimeter 2-pole terminal. Okay, we'll go ahead and route these cables around and connect it. And when you're looking at it from this angle, the ground is on top and the 5-volt is on bottom. Okay, and now at this point everything is assembled. You can button up this board, put the lid on, screw it down, and then we'll get over to the heater and get this installed.
Okay, and now the last step is just to hook it up and test it out. So I've already removed the vent cover from my heater. So what you can do, so take your new pieces. It'll be obvious which gasket goes in which, but this is the base unit. So go ahead, and once the gasket's in there, just go ahead and pop that on. Make sure it's lined up so that this outer rim here fits down inside that recess. Let's see. There we go. Should be a pretty solid fit. Here I've got the new vent cover with the TPU gasket installed, so I'm going to pop that on there. And it should have a little bit of resistance, but it should move pretty easily. And then what you want to do is make sure this is in the closed position, so it's nearest to me. I'm going to take this, and you want the gear, I think I mentioned earlier, kind of in the mid-range of its travel. And so the way I did that was I just put a little mark here to see where one extent was and the other, and then approximately in the middle, that's where I'm going to install it. So I've got this closed. I'm going to slide this on here, plug this into the heater, plug the heater in to the unit, and then plug it in. Now, odds are it's going to work fine right out of the box. It'll go through the calibration. So what it's doing there is it's figuring out what max open and close are for the vent. And you can see here the light's flashing when it's done and turns solid. There we go, it's ready to go. Okay, so to do the to go through the learning process, the way this works is once it's on, have everything off. You can have the main switch on, but don't have the heater or anything on. And then hold the power button down. Hopefully you can see that okay. Let me prop it up here with something. Bring this in where you can see it a little better. So hold the button in until the light goes out and then comes back on. There, it's off. Back on, release the button, and so now it wants confirmation that everything's off. Like I said, you can have the main switch on, but have everything turned off, the heater and the fan. Hit the button once, and it will flash while it's kind of reading that baseline current usage with everything off. And then when it turns solid, you're going to turn the heater and the fan on first. So there's the heater and fan running. I'm going to hit the button again. It's going to flash while it reads what that current usage is. And then when it turns solid again, I'm going to turn this off with the front panel. But now you can see the heat's off, but the fan is still running. So I'm going to press the button again, and it's going to read that. And then when it's done, it'll go back to a solid light, meaning it's ready to go. There we go. And now it's fine-tuned those readings. So it really knows now. So it's closed. So if I turn the heat on, it's going to open. It stays open while the fan's running. But as soon as I turn the unit off, it's going to read that. It should close immediately. So there you go. So you need to do that every once in a while if you change the heater out for another one or any components or whatever, but then it'll really fine tune your settings. So there you go.